In this video, we'll look at simplifying expressions by combining like terms. In particular, we'll focus on a few expressions where the coefficients are numbers with decimals. This will be relevant later in the course when we explore application problems with percentages, as those coefficients are often represented using decimals. So to get started, let's look at this first example. We have the expression 1.2x plus 3.5x. The first thing we want to recognize is that the two terms here are like terms, as they both have the variable x, and it doesn't have an exponent or anything that would make them unlike terms. So what we need to do then is combine their coefficients. So we have 1.2x plus 3.5x. So the addition we need to do is to add 1.2 and 3.5. And I'll add those decimal numbers. I'm going to add them vertically just to make sure I keep things lined up correctly. So I'll add 2 and 5, I'll add 1 and 4, or 1 and 3 to get 4, and so I'll get 4.7. So I know now that when I add 1.2x and 3.5x, I get 4.7x when I combine those like terms. Let's jump down to this next example, and we have p minus 0.07p. There's a couple things we want to note here. The first is that these again are like terms. We have p in the first term, we have p in the second term, so those are like terms. When we think about their coefficients, it's really critical that we remember that that expression p has that implied coefficient of 1. We don't have to write that 1. We know that it's there, but when we combine those like terms, that's the coefficient we'll need to be using. So what we're going to do is take p minus 0.07p, and so we'll look at those coefficients, and we'll just have to subtract those when we combine those like terms. So if we take 1, and I'm going to write it as 1.00, and we subtract 0.07, I'll do some arithmetic here. So I'll cross off that 1, get a 9 here. I'll have 10 minus 7 then to get a 3. 9 minus 0, I know that I'm going to get 0.93. In some contexts, I could do that with a calculator. Here I'm just doing it by hand. So I know that 1 minus 0.07 is 0.93. So when I combine those like terms of p minus 0.07p, I'm going to get 0.93p. Let's jump over to our third example. This one's really similar. I have s plus 0.3s. Again, those are like terms. I have s as the variable in each term, and I want to remember that the coefficient on just that single term s is a 1. So s is the same as 1s. So what I need to think about adding is 1 plus 0.3, that one's pretty quick to do. That's just 1.3 when I put that, when I add those two numbers. So s plus 0.3s is going to give me 1.3s. The last one here does not involve decimals. This one's going to involve a couple of fractions. So we see that we have 1/2 z minus 3/5 z. So first thing we note, again, these are like terms. I have z in each of them. And so what I'm going to need to do is to look at those coefficients. I have 1/2 z, I'm subtracting 3/5 z. So the arithmetic I need to do is to take 1/2 and subtract 3/5. That's going to give me the coefficient once I've combined these like terms. Doing the subtraction, the first one has a denominator of 2 and the second one has a denominator of 5. So I'll need them each to have that same denominator. And the least common multiple of those numbers is 10. So the lowest common denominator I could have is 10. So I'll build 1/2 up by multiplying by 5 over 5. That's what will give me a denominator of 10. And then I'll build up 3/5 by multiplying by 2 over 2. And then that will become 5/10 minus 6/10. Now that they have the same denominator, I can subtract them. So I'm going to have negative 1 over 10 when I take 5/10 minus 6/10. Now that I've done that arithmetic, I can combine these like terms. I have 1/2 z minus 3/5 z. That will give me negative 1/10 z.